Now we are considering 4 examples. In example 1, we wrote println method name. ... We can input by 3 parts: method, text description, variables, and terms. In here, we only write println. We can see that make plugin will make a unique aliases method invocation in your editor. This allows the AST parser to extract source tokens with error recovery. All information about the input query is embedded into a dictionary with a key as the alias name. Then we will translate this result. Second example. In this example, we will write a list of textual description. The expected result can be found in the Nexus Android project. Now we translate the result. We can see that, different from the first example, now print and println will be translated to another implementation. If we provide a printwriter variable, the output of translation will automatically update the final code. Now we add printwriter argument and we see the translated result is close to the expected result. Third example. In this example, we will change to embed info model to be suitable for developers who usually input queries by 3 parts. We input in the result. We show that the generated expression is a method invocations that required 3 variables, a string and an integer. Fourth example. Now, in the fourth example, we switch the input mode, which we allow users to input in natural language. In this scenario, we input 2 textual input queries related to the binary search. Now we see the details of each query. From the input query, the list of method names, variables, and suggested terms are automatically extracted. Their ambiguous entity, the array, which we use rule-based approach to extract and map it to a long array. We can update the method name if we want. In here, I will select the second method name, binary search. Now I have the tokens is. Let's see how the plugin works. In this work, we relied on the ability of learning from the incomplete representation to complete representation of code in Practical Java GitHub project. In the training, we consider source status information about partial class name and method name. In the target side, there are information about fully qualified name and expression id for each method invocation. The expression id is represented by expression code, required local parameters to run, and required import API like this example. In the testing phase, we aliasing each user input query and process it to source tokens. In mode 2, which allows users to input by natural language, the query will be automatically extracted 3 parts of information to produce the source tokens. We automatically split information about variables in the query by an entity detector and getting list of method names by minimum editing distance comparison with dictionary. There are two models of translation, the compact model and embed info model. The compact model is learned from the data, contains method name from source and expression id from target. The embed info model embed other information of method invocation, including information about type of local variables and some important terms. In the training, we proposed a machine translation model based on phrase-based translation to learn the mapping from method name to expressions. In the testing, the tokens extracted from input query will be combined to tokens extracted from other elements to make the input for translation. The output of translation will be compared with list of local variables in the testing site and will be updated to final code. In overall, we conduct a method that allows developers to write multiple queries into a program and get result as the most complete code by considering each query as an element for translation. In the other words, the result of a queries are related to each other.